All right, here we go. Can you believe that this is the last topic of the freaking semester? Woo! Amazing. What? Unbelievable. Congratulations, seriously. You've kept up with the pace. You've done it. You are amazing. It hasn't been easy, hasn't been far from normal, but you've done it. Good for you. All right, this unit is going to seem a little disjointed from the rest of what we've been doing. Most of what we've been doing, all of what we've been doing, this unit has been let's get to be able to solve trig equations and prove trig identities, right? Like the last video you watched, I was talking about all these tools in your bag. This is a separate topic, a separate objective. And the only reason we put it here was because it does involve some trig. So you are going to have some, so we wanted to do it at the end of trig, right? So that you remember all your trig information, but it really is not tied to solving trig equations or proving trig identities. And it is an objective that it uses some trig, but where you're going to actually apply this won't be until second semester. And not the beginning of second semester. It'll be like the end of third quarter, beginning of fourth quarter. Okay, so our goal is to take a linear equation from Algebra 1 and put it in standard form. That's a little bit of a lie. It'll be given to you really in standard form. And standard form, remember from AAF, was AX plus BY plus C is equal to 0. Now, of course, you can get Y by itself, right? And you could get it into point slope form or slope y-intercept form. And your slope would be negative a over b, right? Because you would subtract a and then you would have to divide by b, and then this multiplier would be on x. But I am going to give you something called the normal form of an equation. That's new. Standard form is old news. This is new news. And then we are going to use our new equation to calculate a distance, right? And distance is positive, certainly, between a point and a line. So for instance, I have some random point P here, and maybe I have some random line here. What is the distance? And remember, distance is defined to be shortest distance. What is the distance between that point and this line? Right now, there are a variety of ways to do that, but I'm going to give you one way and a fairly concise and quick way, which is why this is an objective. A fairly concise, quick way to compute this distance between the point and a line. So let's do some review of Algebra 1. Write the equation of a line perpendicular. A synonym for perpendicular is normal. But we can use perpendicular in as a large set. When we use the word normal for perpendicular, we generally say, we really do name it. We are considering a particular point. So here is a line that is not in standard form, by the way. This is in slope y-intercept form, right? But I pass through the point 1, 4. You did this in Algebra 1. We did this in AAF. So negative 2x plus 7. Here's the y-intercept of 7. This slope is negative 2 over 1. There's my perpendicular, or my normal. My normal is orange. I guess I don't have orange. This is my normal line. We call that N. What is the angle at their intersection? Hello, right? To be perpendicular, you have created right angles. Now, I want you to take this equation and transform it into standard form. Do you remember how to do that? Okay, remember, standard form is AX plus BY plus C with some restrictions. Do you remember that? A, B, and C were elements of the integers. A had a further restriction that it had to be a positive integer. And we practiced this objective in AAF with no context. We just said, practice doing this. So transforming this into standard form, no big deal. I'm just going to move the 2x over. So I have 2x plus 1y minus 7 is equal to 0. A is positive, B and C. A is a positive integer, B and C are integers. Check. I'm in standard form. Okay, so prerequisite knowledge. A normal is a line that is perpendicular to another line through a given point. However, in multivariable calculus, we use normals a lot. Same kind of thinking, but instead of normal to a line, we're normal to a surface. So in 2D, here is a point to a parabola. Here is a specific point. The blue tangent line is kind of sweeps by and kisses the function, the parabola, but the normal runs right through it. It's kind of rude, but you create right angles here, right? Tangent and normal to the curve at a given point. Again, once you get to multivariable, we start to do from, instead of 2D space, we do 3D space. Still, we pick a point. I can be tangential to this point, right? Going along the surface, just kissing the surface at this point, but I can also point out and be normal and create a right angle. So there's my line. The normal form of this green line is going to define this line not in terms of its slope and y-intercept or in terms of its intercepts. Okay? It's going to define the line in terms of the length, which is positive, of its normal from the origin, as well as the positive angle that the normal, which is perpendicular through a given point, makes with the x-axis. So there is a normal that goes through the origin to a specific point on my green line. P is the piece, get it? P for piece. P is the piece of the normal from the origin to the line at that given point. It is a distance. Phi is the angle that my normal line, as well as the piece of the normal line, makes with the positive x-axis. So, can you tell me about the coordinates of this point of intersection? So I've named it, right? Here it is, but I haven't said the coordinates. Can you think about what the coordinates would be? Does that make sense? Come on in, Pythagoras. I mean, he just never goes away, right? He's always there. What is this x distance? The x distance to the point and the y distance to the point comes from Pythagoras, right? Pythagoras and our right triangle trig. So right triangle trig The cosine of this angle is x over p, so therefore x must be p times cosine theta. And the same for y. So this is x equals y equals. How about the slope of the normal? What's the slope of the norm? Slope is always rise over run, isn't it? Y over x, isn't it? Well, what is my y? And what is my x? Hello. The slope of the normal. The slope of the normal is rise over run. Y over x, but what happens to the p's? OMG. Sine over cosine. Well, what's the slope of the given line, the green line? What's the slope? What's the relationship between slopes of perpendicular lines? Negatize and flip, baby. Right? OMG. I have the slope of my given line defined in terms of trig. So let's write the equation of the green line, not the normal, the green line. Point slope form of a line. Y minus the y coordinate is equal to the slope, x minus the x coordinate, right? Point slope form of a line, best friend. Well, what was my y? Your x, point of intersection, right? X and y at the point of intersection. And what's the slope? Say, what? Right, just point slope form of a line, that's all that is. Now I want to clean this up a little bit, okay? I don't want fractions. I have an equal sign and I don't want sine phi in the denominator. What can I do? Multiply through by sine phi, right? So I have y sine phi minus p sine squared, and then my denominator went away. Now I want you to distribute that cosine. And I want you to collect everybody on one side. Algebra 1, that's all this is. Algebra, collect everybody on the left side. Good F word. Factor the P. Come on in, Pythagoras. Come back, come back. Here's my Pythagorean identity. Oh my gosh. That's 1. This is the normal form because I used the normal to this given point to make the equation of the line. Given point with P, the distance from the origin. Right? What is that? What is this distance? What is, right? If you wanted the distance, wouldn't you just Pythagorize this? Right? Well, what's my x? 0 sine phi plus 0. If I wanted the distance of this line to this point, right? I can put this in and then I can put that, right? Do the distance formula. Guess what I'm going to get out of that? P, the distance from this green line to this point P, I'm sorry, to the point origin is P. I built that in. So let's do an example where I don't want you to use it. I just want you to practice transforming. Write the standard form of the equation of the line, but I'm giving you the length of the normal from the origin, and I'm giving you the angle that the normal makes with the positive x-axis. There you go, right? P is 11 and phi is 330. Bam, there I am, done and done. Now, what if I want you to convert from standard to normal? So I give you standard, or I give you mx plus b and you put it into standard, or I give you point slope and you convert it into standard. From standard form, how do you get to normal? So remember, standard, this is why an objective in a prerequisite class was if you have point slope or slope y-intercept, you need to get to standard form, then you can go to normal. So take standard form, use Pythagoras on A and B. You want to choose, the reason I have plus or minus here, you're not going to divide through really by plus or minus. You're going to choose the sign that makes the constant p positive, right? You want p to be positive because there's already a negative in the equation. The length of the normal is p, the angle, right? So if so there's my p. Now I want the angle. Is the coefficient on x and sine is the coefficient on y, right? So you've got A is equal to cosine phi, B is equal to sine phi after you divide through. So let's write the normal form of the equation. So I'm in standard form. Where I've got capital A, capital B, and C. Determine the length of the normal. What is P? So first I do plus or minus, right? A squared plus B squared. There's my 2. So I'm going to divide everybody by 2 for my angle. So I took A divided by 2, took B divided it by 2, took 8 and divided it by positive 2. Why did I do positive 2? My choice was positive because I wanted this value to be positive. So P is 4. Cosine phi is root 3 over 2. Sine phi is 1/2. What is that situation? 30 degrees, right? What angle has a cosine of root 3 over 2 and a sine of 1/2? Positive. I mean, of course, you could also think who has a tangent of 1 over root 3, right? And because I told you degrees, I asked you for degrees, you give me degrees. If there had been no marker there, you would give me radians. Let's do one more. Write the normal form of the equation in mx plus b form. What do you have to do first? Prequel step. Negative x plus y minus 3 is equal to 0. Is that standard form? No, right? You have to know your conditions or you won't get this problem right. That's why this was an objective in AAF. Multiply through by a negative. Positive x minus y plus 3 is equal to 0. Whoops, sorry. So how do I find P? Right, the sign doesn't matter here. Right? If I had not remembered about the conditions on standard form, it wouldn't have mattered for Pythagoras because I am just squaring both of those. Right, so that's okay. Now what am I going to do? I haven't made a decision yet about how I'm going to write this. I'm going to divide everybody, so I have x minus y plus 3 is equal to 0. So I'm going to, if I divide everybody through by positive root 2, what happens? I need this value. Remember, my form of the normal so this is really a double negative. I can't have that. So I actually needed to choose my negative this time. So what do I have? X cosine negative 1 over root 2 plus y sine positive 1 over root 2 minus 3 over root 2 is equal to 0. So what's P? Or 3 root 2 over 2, whatever you want. What is phi in degrees? Who has a cosine of negative 1 over root 2 and a sine of positive 1 over root 2? I'm in quadrant 2. Now, why do I want to use this? So this was just practice. But what is it used for? So it can be challenging. I can do it, but it can be challenging. With the normal form, the distance to a line, as long as the line is in normal form, is just the normal, is just the absolute value of the equation, where here is your given point. So if I want to find the distance between 2, 5, and this line, what is this line? Right? If you want to see what this line is, y is equal to negative 5x minus 1, all each divided by negative 12, right? Something like that. What is the distance? Get your equation into standard form. See, I chose the negative. So negative 5 over 13x, 12 over 13y, and minus 1 over 13. The distance is 2. There's my x times negative 5 over root 3. There's my y, 5. There's my distance. Crazy, right? And again, we will do more of this, use this more second semester. And I'll say to you, remember when we did at the end of first semester, we used the normal form of a line to calculate the distance from a point to a line. And I won't go through and have you practice again writing, writing the equation. But you do need, I won't give you practice in it, but you need to remember that I need standard form of the line and then how to transform from standard into normal. And then once I'm there, I just absolute value stuff. I just plug and chug an absolute value. Right? Congratulations! Woohoo! The last topic in semester 1. You did it. You did it. All right. I will see you in our next live session.